Welcome, boys. Now, again, we have this video related to integration by parts as well as the spatial form. Now, here today I have to complete this integration by parts and also the spatial form integrals. Now, let us start with a numerical. Now, in this integration by parts, we have few special type of problems like I is equal to integral e power ax cos bx dx, or I is equal to integral e power ax sin bx dx. Boys, in method of substitution, I have already told you that exponential integrations are of basically three types. And two types we have already discussed earlier. Now, this is the third one, and it is also a type of exponential integration. Now, this type of integrations we have to solve using integration by parts. Now, how to solve? We will try to solve any one of these two, and similarly you can solve the other one. Now, let us start with the first integral, that is integral e power ax cos bx dx. Now, how to solve this integral? You see here, whenever you approach such type of integrations, we always take Euler rule, that inverse, log, algebraic, trigonometric, and then last one is exponential. So this function should be the second function and this one is the first function. So what to do? We have to write it as integral cos bx dot e power ax dx. Now, to solve this, we will apply the formula for integration by parts. And that, as per that formula, we have to write cos bx. The integral of e power ax, if you observe, it will be e power ax by a. Then minus integral, differential of cos bx is minus b sin bx. And further, integral of e power ax is e power ax by a dx. So this result you will get after applying integration by parts. Now we can write it in a systematic manner, that is e power ax cos bx divided by a plus b by a. Again we have sin bx into e power ax dx. Now you see, in the second one, in second part, again we have to apply integration by parts. Now, what will be the result? We will write it further. So what happens? This becomes e power ax cos bx divided by a plus b by a. Now we write third bracket. Here we should write sin bx. The integral of e power ax is e power ax by a. Then minus integral sin bx, the differentiation is b cos bx, and then into e power ax by a whole dx. So this result you will get. Now you have to close the bracket here like this. You have to close the bracket. After that, we will try to open this bracket. Now what happens? You see, that is e power ax cos bx divided by a plus, here you will get b by a square e power ax sin bx, and then minus b square by a square. Here it is I, b square by a square into I. Why I? Because b by a, this comes out of this integration. Now b by a to be multiplied by b by a, it becomes b square by a square, and whatever remains here, that is integral cos bx e power ax dx. Now cos bx e power ax dx, we have already taken it as I. So just we have written I here. Now this process is common to all the problems which are of this form. Now you have to operate this total process while solving the problems based on this form. Now what happens? This I term should be taken to one side. Means here we have I, here we have I, and this I, this term I should be taken to left hand side. That is I plus b square by a square into I is equal to, here you can take the LCM. LCM is a square. And in the numerator you will get e power ax into a cos bx plus here you will get b into e power ax sin bx. So this thing you will get. Now further, take the LCM, take I common here, and whatever remains in bracket, you should take the LCM. Now what happens, you see here. If you take I common, you will get in the bracket a square plus b square by a square, bracket closed, is equal to, here you can take e power ax common, that is by a square. In the bracket you will get a cos bx plus b sin bx. This thing you will get. Similarly, here you find a square cancels out, and therefore I is equal to e power ax by a square plus b square, and in the bracket you will have a cos bx plus b sin bx. So now you can add, for I you can add here plus c, and this c acts as a constant of integration. Now this constant of integration must be present while solving all the integrals. So here we have our this result, and for commerce students this is your final answer. But for some intelligent student, we will try to present this answer in some systematic form. How? You see here, we can write it as e power ax by root a square plus b square. In the bracket, you can write a by root a square plus b square cos bx plus b by root a square plus b square sin bx, and then plus c you can write. Here a square plus b square can be written as root a square plus b square into root a square plus b square, 2 times. One root should be taken within this bracket. This plus c remains there. Now what happens? If you take this result as cos alpha, say, then this result will be sin alpha. This result will be sin alpha. If you take cosine of any angle, because you see here numerator and denominator is greater than numerator. So this ratio is always smaller than 1. So we are able to take it as cos alpha. Now if this is cos alpha, this will be sin alpha. Or you can take this one as sin alpha, this becomes cos alpha. But it is preferable to take cos with cos. Now, what happens? Here we can write let a by root a square plus b square is equal to cos alpha. Therefore, b by root a square plus b square is equal to sin alpha. And therefore, tan alpha is equal to b by a. Sin by cos, b by a. Therefore, I is equal to e power ax root a square plus b square in the bracket, curly bracket, cos alpha cos bx plus sin alpha sin bx, and then plus c. This result you will get by taking this one as cos alpha and that one as sin alpha. You will get this result. Now this is a formula, cos A cos B plus sin A sin B. It becomes what? E power ax by root a square plus b square, here cos bx minus alpha plus c. Boys, do not write alpha minus bx. Do not write, because in terms of cos bx minus alpha, we should write here. Now the value of alpha is tan inverse b by a. Alpha is tan inverse b by a. You must put here. So you will get e power ax by root a square plus b square, and then cos bx minus tan inverse b by a and then plus c. This is your integral. And which integral is this? This integral is integral e power ax cos bx dx. So the value of this integral is this one. This one. Similarly, if you try to solve e power x sin bx dx, instead of cos, if you take sin and if you operate like this, as previously we have done, you will get the answer as e power x by root a square plus b square. In case of cos, we are getting cos. In case of sin, we will get sin here. That is sin bx minus tan inverse b by a plus c. But remember, this formula only applicable for competitive exams. Do not try to apply this formula in HS. You have to derive this formula. You have to do all the steps what I have done here in higher secondary. This formula is restricted to use in HS exam. You can apply this formula for solving the problems based on competitive exams. Now, suppose we have integral, say we have integral e power 5x sine 3x dx. Now you can observe that in the place of a we have 5, in the place of b we have 3. So do not try to apply the formula in HS. Remember it. For competitive exams, you can remember the formula that it is e power ax by root a square plus b square sine bx minus tan inverse b by a plus c. That will be your answer. So you have to write the answer directly in case of competitive exams. But here you have to take it as I. Operate integration by part 2 times. Once again you will get I. Take the term containing I to one side, take I common and then find out the value of I. So I think you can now able to solve such type of problems. Whereas similarly we have few problems which are not visible to this form but they are of this form. For example, integral. They are very, very important problems. Cos log x dx. See, cos log x dx. Some people directly use IBP to solve this problem, but it is advisable to take log x as z. Let log x as z. Then you will have x is equal to e power z, because here the base of log is e. So x is equal to e power z. Therefore dx is equal to e power z dz. Now what you will get? Therefore I is equal to integral cos z into e power z dz. Now you are able to understand that it is of the form e power ax cos bx dx. Here a is equal to 1, b is equal to 1. So you can write the answer directly, but not in HS. For HS you have to perform it. I am writing the answer directly here, that is e power z by root 2, then cos, in case of cos, then bx minus z plus minus tan inverse 1 b by a plus c. This tan inverse 1 should be written as pi by 4, and in the place of z again you can write log x, that is here log e power log x is x by root 2, then cos log x minus pi by 4 and then final answer plus c. So this will be your answer. X by root 2 by root a square plus b square, that is a square plus b square is 1 square plus 1 square, that is 2. So x by root 2 e power z, z means log x, so e power log x is x. So x cos log x minus pi by 4 plus c. So this is your final answer. Now we have few integrals of the special form. Now boys, you can solve some special form integrals which are given to you, and they are of the form integral dx by a plus b cos x, or integral dx by a plus b sin x, or integral dx by a cos x plus b sin x plus c. This type of integrations. You may have this type of integration in your exam. Now to solve such type of integrals, there is one general method. Always apply cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. You have to write. Similarly, sin x you have to change, that is 2 tan x by 2 divided by 1 plus tan square x by 2. You have to convert sine or cos in terms of tan and then put tan x by 2 is equal to z. Now remember, if you differentiate it, you will get sec square x by 2 into half into dx is equal to dz. Why this half? You must keep in mind that here we have x by 2, so the differentiation of x by 2 is half. Now what happens? Sec square x by 2 dx is equal to 2 dz. Now boys, if you take this substitution after converting cos and sine in terms of tan, your integration will be easily integrable. Now one more thing you must keep in mind, for these two problems, if we may have cos x or cos 2x or cos 3x or whatever it may be, you have to convert in terms of tan. For here, whatever be the angle in front of cos, say it is x, then the same angle should exist in front of sine. The two angles must be same. Let us take an example. Say we have to integrate, you see here, integral I is equal to integral dx by 5 plus 4 cos x. Now, to integrate this type of integrals, we reduce this cos x in terms of tan. So what happens? This is equal to integral dx by 5 plus 4 and then 1 minus tan square x by 2 by 1 plus tan square x by 2. So this thing you will get. Now if you take the LCM and invert it, you will get integral sec square x by 2 dx by, here you will get 5 plus 5 tan square plus 4, that is 9, and plus tan square x by 2. You can get this result after simplification. And further, if you put tan x by 2 as z, put tan x by 2 as z, what you will get? You will get this as 2 dz, just we have told you. So 2 dz by 9 plus z square, and it is of the form x square plus a square, standard integrals. We have discussed it earlier. So this 2 comes out and the final answer will be 1 by 3 tan inverse z by 3 plus c. Now what happens? This is 2 by 3 tan inverse. The value of z is what? The value of z is tan inverse tan x by 2, tan x by 2 and then by 3 and then plus c. Now a common mistake which students will do here is that they think that this tan inverse and this tan that disappears. No boys, this will never happen, because in front of tan inverse we have tan x by 2 divided by 3. Unless we should have 3 here, we cannot disappear this. So we know the formula that tan inverse tan x is equal to x. But here, if in the place of tan x we have tan x by 3, how you can remove it? So it is not possible for you to remove this. So do not try to remove. You whatever is here, you just write this is your answer. So the answer will exist in this form. Now, one more special type problems we have to do here. Say integral dx 2 sin x plus cos x dx by sin x plus 3 cos x. Remember boys, if you are getting function of sine and cos, always integral which is function of sine x as well as cos x dx divided by some function of sine x and cos x, sine x comma cos x here. Then to solve such type of integrals, where in numerator we have sine cos, denominator also we have sine and cos. If we have here in numerator simply dx exists and in denominator we have sine and cos, then what to do? In that case we have to convert it in terms of tan, But as soon as we are getting sine or cos or both in numerator as well as in denominator, you have to operate this type of integral by a technique, method. What that technique? First of all, take it as I. Number one, let numerator, that is capital N power N, numerator, I am writing this, is equal to L into denominator. L is a constant, L into denominator plus M into ddx of denominator. Remember it. This is the rule which we have to follow. We have to express numerator in terms of denominator, and to do that we have a technique. If you operate this technique, this numerator can be expressed in terms of denominator. How? You see here, that is 2 sine x plus cos x is equal to L into denominator is sine x plus 3 cos x plus M into the differentiation of sine x is what? Cos x. And then differentiation of cos x is minus sine x. So we'll get minus 3 sine x. We'll get here. Now, if we take sine x common, what we will have? If we take sine x common, we will have L, and from here minus 3m. Just open these brackets, and take sine x common, you will get this. Plus, if you take cos x common, you will get 3L plus M. This thing you will get. Now, we will try to compare the two sides with their coefficients, sin x plus cos x. You see, coefficient of sin x is 2, coefficient of cos x is 1. So, from both sides, we can equate the coefficient because this one to be taken as an identity. Now, therefore, L minus 3m is equal to 2 and 3L plus m is equal to 1. So this thing you will get. Now by solving these two, we will have the value of m and n. So how to solve? You have to multiply it by 3 and here it by 1. So what happens? You will get 3L minus 9m is equal to 6. Here you will get 3L plus m is equal to 1. Now simplify, subtract, minus, minus, minus. So what you will get? You will get this 3L cancels out. Minus 10m is equal to 5. So m is equal to minus half. Now this value of m, if you put here, that is minus half, it becomes plus 3 by 2. When it goes here, L is equal to half. L comes out as half. Plus 3 by 2. Here 2 minus 3 by 2 LCM, that is 1 by 2. So L is equal to half, m is equal to minus half. So now how we can express? Therefore, you have to write, it here. Therefore, 2 sin x plus cos x, that is numerator, is equal to L means half, that is sin x plus 3 cos x, then minus half, that is cos x minus 3 sin x. So this will be the value of numerator. This should be taken as number 2. This is our process how to get the value of L and M, and after getting L and M you have to put this value here in this result. You will get numerator in this form. Let us verify whether this will be the value of numerator or not. Let us verify it. You see here, if you take the LCM is 2. Now in numerator you will get sin x plus 3 cos x, and here you will get minus cos x plus 3 sin x plus 3 sin x. Now plus 3 sin x and 1 sin x, it becomes 4 sin x. And 3 cos x and minus cos x, it becomes 2 cos x. So 2 cos x, 4 sin x. You can take 2 common, 2 and 2 cancels out. You will get 2 sin x plus cos x. So at first we are unable to understand that how this half and minus half will appear. So that's why we perform this act, so that we will get the value of L and M. Now once you get this value, you should write the value of numerator as this one, so that this integral is easily integrable. Therefore I is equal to integral, that is half sin x plus 3 cos x by sin x plus 3 cos x, then minus half cos x minus 3 sin x, and then at last dx. Now break this integral in two parts, that is this by this. So these two cancels out, half comes out, it becomes half integral dx, minus half comes out, integral dz by z. Why dz by z? If you take z as sin x plus 3 cos x, if you differentiate it, you will get cos x minus 3 sin x dx is equal to dz. So it becomes dz by z. And final answer is x by 2 minus half log mod, the value of z will be sin x plus 3 cos x, mod closed plus c. So in this way, you have to solve the problems based on function of sine and cos by function of sine and cos. So boys, this is all about the special form. Now from the next turn, we will start definite integrals, and we will try to complete the definite integral as early as possible, because whatever we have learned in indefinite integral, that all technique should be applied in case of definite integral. So we will try to complete definite integral as early as possible. Thank you boys.